what we're going to do is we're going to find out the centre of mass for this shape. Now this shape, we're going to do all the measurements are in millimetres, all in millimetres, and we have a lump of aluminium 6 mil, a lump of steel 8 mil, another lump of steel 10 mil. So we know from before that the centre of mass, and we're going to have to find out in the x dimension and the y dimension, is equal to the sum of the mass times the distance over the sum of the mass. Now that's good, but how do we work out the mass? Well, the mass is equal to the density times the volume. And the volume itself, volume is equal to the area times the thickness. So we're just going to have to be careful of conversion units here. So what we do is we break up this into 3 areas, and that's already done. These are all rectangles. So 1, 2, 3. I can work out number 1, number 2, number 3. I can then work out the masses for each of these. Okay, so how do we work out the masses? Mass 1 is equal to the density, which is going to be, because this is aluminium, remember we've got to be careful with the units here, so this is 2,800 kgs per cubic metre, times the area, which is going to be 10 millimetres times 20 millimetres, 10 millimetres times 20 millimetres, times the thickness, 8 millimetres. Okay, and you've got to remember these are all millimetres, so we may want to convert these to metres to work out the mass. So 0.1 metres, 0.02 metres, 0.008 metres. If we do that, we go 2,800 times 0.01 times 0.02 times 0.008, that's 6 millimetre, isn't it? 6 millimetre, so times 0.006 equals 0.00336 kg. I might just do this in grams because it looks like, which is equal to 3.36 grams. Let's do it in grams because that makes it easier. So this is 3.36 grams for the first one. Mass 2 is done the same way, equals 6,800 times, let's do it in metres, it's going to be 0.01 metres, 0.01 metres, 15 metres times 0.0808 metres for the thickness. So it's 6,800 times 0.01 times 0.015 times 0.008 equals 8.16 grams. And number 3, we do the same way. Mass 3 is equal to steel again, 6,800 times 0.01 times 0.01 times, well, it's 10 mil, 0.01. So that's equal to 0.01 cubed times 6,800 equals, strangely enough, 6.8 grams. 6.8 grams. And now what we do is we sum those all up. So the sum of the masses equals 6.8 plus 8.16 plus 3.36 equals 18.32 grams. Okay, so it doesn't really matter what units you can use. You can use in kilograms or tons or milligrams. Because we've got mass above and below, it'll cancel out as long as you do the units all the same. Okay, so the distances for 1 in the x dimension, dx is going to equal half of the length, so 10 This is going to be 20 plus half the length is 25, and this is going to be 30 plus half that length because these are all rectangles, so 20, 35. So we go 3.36 times 10, I didn't even need a calculator for that, 33.6, 8.16 times 25 equal 8.16 times 25 equals 204. The third one is 6.8 times 35 equals 238. And this is the mass times the distance. That gives us the top number here, so we sum those up. So we go 238 plus 204 plus 33.6 equals. So this number is 475.6. And then what we do is we work it out. We go centre of mass, x equals 475.6 over 18.32, because we worked out the centre of the mass here, divided by 18.32 equals 25.96 millimetres. So we can say 25, just over halfway here, 25.96. Yeah, okay, that's a bit ugly for bigger. Then we do the same thing with the y, dy. The dy's, the first one's going to be halfway up, so 5. The second one's going to be halfway up, 7.5. The third one's just going to be halfway up, 5. So we go 3.36. 3.36 times 5, 16.8. We go 8, we take the multiply the mass times the distance, 8.16 times 7.5 equals 61.2. And the third one, we go 6.8 times 5 is, so what's that, 34, yep. So then we just add them all together, 34 plus 61.2 plus 16.8 plus 61.2 plus 34 equals 112. That's mass dy. And so centre of mass y is equal to that number, 112 divided by the mass, 18.32. That equals 6.114. So it's going to be 25.96 along, 6.154, 114 up, where the two lines meet. That's where your centroid's going to be. Bingo, done. Yeah. Okay, so again, just like you do with centroids, if you've got a hole in there, just treat it as a negative mass. Okay, so you're removing that much. So if you treat, when you have voids and holes, you can just count it literally as a negative mass. And if you use negative number in there, it will all come out in the math. So good luck on centroids, good luck on centre of masses.